Okay, so right, so we are live. Fine, guys. Okay, so good evening, guys. Good evening, everyone. Good evening, and welcome back, guys, once again to Rio Academy. So I hope my voice is clear and you can see me, right? Okay, guys. So to all those aspirants who are preparing for the PGCT examinations, PGCT 2024, guys. So we at Rio Academy have been conducting the classes on YouTube. So join in, guys, daily live on YouTube classes. Simultaneously, we are also conducting the classes on app. So as you all know, guys, the PGCT examination for MCA has mathematics to be on a very high basis. For MBA students, mathematics is not that on a vast basis, but for MCA it is. So in the previous sessions, we have covered up some of the topics, guys, and questions related to trigonometry and inverse trigonometry. I hope you have gone through those sessions too. If you have any doubts within those sessions, guys, please let us know in the comment section. And if you are able to understand, do like those videos. And I'd also like to inform you guys, in order to subscribe to our channel, so that notifications will be brought to you whenever we are going to be conducting the classes. Alright, and about the classes, guys, all the classes will be conducted on an online basis. For that, you'll have to download up the app, Rio app, from Google Play Store. Of course, the link has been given out in the description. Download the app and you can find the various details there. If you have any doubts or errors, you can directly contact us, guys, at the contact number provided in the description. Join us also on the WhatsApp group. Join us also on the Telegram channel, where all the aspirants who are preparing for the examination are present, and you can form a well-developed community there and lead out to various discussions. Before starting up with today's class, guys, let me inform you something regarding myself to many of those aspirants who are watching me for the first time. I'm an engineer, guys, professionally. I still am, and I'm an educator by passion, out of interest. I have been into the competitive world, guys, related to this for more than about 6 years now. So not only for PGCETs, but also for CA, IBPS, UPSCs, KPSCs, and so on. So that experience is what we are going to guide you out in order to prepare you for the PGCT. Alright. So nonetheless, guys, today we are going to start out with the topic. The topic is quite easy that we are going to be dealing with, and that is nothing but the trigonometry part. Okay, sorry guys, I'm just kidding. It's just the topic of matrices. Alright, so matrices, we have uploaded one more previous session, guys. Do check out that video too. This particular topic is very easy topic. You can expect only guys, 2 or 3 questions from matrices topic, not directly but indirectly. You can expect the questions on an indirect basis, like the questions can be related to the part of equations. The questions can also be related, guys, to the part of what to the part of linear and simultaneous equation. Okay, so now we are going to deal around with the matrices part, guys. Once again, there is nothing new that we are going to deal around. We are just going to discuss out the basics, some of the concepts, and some of the different types of matrices. Alright, so now, guys, we are going to come back to the part that we had left out in the previous session. So I am just going to take out the PDF format, guys, because we are quite aware of what matrices are. So I am just going to tell you what are the reasons and why is that so particularly. Okay. Okay, so I hope it is visible, guys, on your screen. So there isn't much really to discuss about this particular topic of matrices. I'm just going to tell you the reasons and the questions that you can expect out from this part in your PGCT preparation. The algebra of matrices, the first part that we have, guys, is the scalar multiplication. Say scalar multiplication means you must be quite well aware, guys, of this particular term, scalar. We had 2 different quantities, guys, whenever we were dealing with. Scalars was the first part and vectors was the another part, correct? So scalar is basically a term, guys. What is this term? It is just a term which means measurements. Okay, measurements. We are just going to measure out whatever it might be. It might be length, it might be breadth, it might be the weight. We are just going to take out the measurements here. So measurements once again has a new different terms in terms of the physical world and also in terms of mathematics. That is nothing but scalar, and hence that is the reason, guys, scalar means those quantities which have only magnitude but not direction. We have learned that. Okay, magnitude means what? It is just about measurement. We are not concerned about the direction format here, unlike in like in vectors. Okay, scalar just means a number, guys. It can be any number, it can be an alphabet, it can be a constant, it can also be a variable. But basically in the part of matrices we take scalar to be a constant. So what happens when we multiply a matrix by a constant or by a magnitude or by any other number? That is what basically the scalar multiplication suggests. See, I'm just going to take down one example here, guys. Suppose there is a matrix 1, 2, 3 and 4. There are 4 different elements here, and order of a matrix I have explained you why we call it as order and why not directly the number of elements. What is the difference in between the number of elements that we take around in sequences in tabular arrangement, and why do we particularly represent that in form of order in this particular topic of matrices. Okay, so nonetheless 1, 2, 3 and 4, this is a matrix, and if there is a scalar means I told you it can be anything, a number, it can be a variable, it can be anything. You can also take it to be particularly a constant. So I am going to take out one scalar value here to be 2. So I am just going to multiply, scalar multiplication. I am going to multiply this magnitude or this measurement or number or element or constant or variable to each and every particular term here. So I am just going to multiply it, guys. 2 into 1, that is nothing but 2. 2 into 2, nothing but 4. 2 into 3, 6. 2 into 4, 8. So this value that we have gotten is nothing but the scalar multiplication result. Okay, nothing different, just the same value. Only with respect to the terms, many of the students find it newly, it might be something complicated. Okay, that is what they have written here. Here he has represented, if A is a matrix ABCD, then K into A, where K, guys, is a scalar element. We have taken that to be a constant. We are going to multiply each and every term of the given particular matrix with that particular constant K. Okay, that is all about scalar multiplication. Now addition of matrices. See, guys, whenever we are to carry out the basic operations of mathematics like addition and subtraction, you can only do so whenever the matrices have same order. Okay, whenever we have the same order, only then we can do it so. Now the question comes to why there needs to be same order? Because see, guys, a matrix represents what? Basically it represents the elements, correct? And if you wanted to add out these particular elements to some different form of a matrix, let me just take it as 7, 8, 1 and 2. Okay, so basically matrix means what? It is an arrangement. We have arranged this 3 number or element at the first position, first row and first column. So whenever, guys, we have to add out, we basically go out with the same positions. Now the question comes as to why do we basically add out the same elements? That is the role of the matrix. Okay, that is the rule, yes, but why we have made that to be the rule? We could have added even the diagonal elements, or we could have done any rule that we wanted, because it is we who are deciding it. Okay, we have done only with the respective elements, because this entire format, we in a resultant format, we should get a matrix also in the same format. It means, suppose we have 1000 different matrices. Okay, there is a set of 1000 different matrices. If we keep on, instead of these respective elements adding out, if we had set out some kind of a different rule, we would have been unable to understand this final matrix. How do we got it? Understanding, if there are 1000 matrices, we add each and every element, first row and first column element of this particular matrix, first element, first row, first column of this particular matrix. Once we get out the final matrix, here it is only 2 matrices, That is the reason we'll be able to understand. But in case if there are 1000 matrices, we won't be able to know how this particular element arrived. If there are too many number of complications, too many number of rules, so it will be very much complicated. Then the entire procedure will have to take out on a very complicated and a very complex basis. In order to avoid that, we have basically done this. So 3 plus of 7, nothing but 10, and second term 8 plus 4, nothing but 12, 5 plus of 1, nothing but 6, 6 plus of 2, nothing but 8. Alright, so basically guys, addition or subtraction, if you have to do something for a respective particular matrix, order needs to be same. Okay, this is a very simple question guys, but this simple question has been asked in your examination. Okay now, so now guys okay, so I'll just suggest something here. Say matrices are completely different. Okay, the value of matrices is completely different. There are certain rules we have with respect to matrices. You should remember that. In case of matrices guys, commutative law holds true only for addition. Okay, commutative law. What does commutative law suggest? A plus of B equals B plus of A. Correct? This is commutative law. Communicative. Okay, that is this derived from communicative. ಆ word ಇಂದ ತಗೊಂಡುಕೊಂಡಿದ್ದಾರೆ. A plus B is equals B plus of A. This law applies only for addition guys, in part of what? In case of matrices, but not for multiplication. It will not hold true for multiplication. Okay, and even the associative law, associative in the term associate means you have to join in together. So joining in means what we do here, A plus of B, we are taking in A and B together, associating them, plus of C, and this is equals to B plus of C plus of A. Okay, or you can also write this to be A plus of B plus of C, A plus of B plus of C. Okay, and remember guys, this commutative law and associative law will not be applicable to the multiplicative format. Okay, so now once again guys, there is also this particular of scalar multiplication, which I told you. Scalar multiplication is nothing but K into A plus of B. Suppose we have two different matrices A and B, and if you are directly multiplying the scalar element, this will also hold particularly true for individual matrices also, right? If there is a constant, you are initially multiplying two matrices A and B, adding them, A and B, adding them, and then you are multiplying a constant. You can also get the same value by multiplying this particular scalar or a constant to individual terms, and then take out the sum of those both matrices. Okay, these are the basic laws which I don't think you will be very much on a difficult basis in order to understand. Okay, so now guys, we'll just take in one more next term here. Now it comes to guys the next part, that is nothing but symmetric matrix. Okay, see guys, the topic of matrices is a very easy and a very conceptualized based topic, so that is the reason why I'm not explaining you in detail of furthermore what are these elements, so on and so on. So symmetric matrix, as you might be quite well aware of, what do we do is we take out the transpose. Okay, what do you mean by transpose guys? Transpose of a matrix 1, 2, 3 and 4. Suppose this is a matrix, and if I am to take out the transpose of this one, we convert the rows into columns. What's the row here? 1, 2, we write that in form of column. 3, 4, we write that in form of a column. Okay, and now guys, in case of a symmetric matrix, symmetric means overlapping. Our body is symmetric. It means if I cut our body into two equal halves, my right half and left half will both be identical. I can overlap them. Okay, they can lie over each other perfectly. Or let me take an example of a leaf. Even leaf is a symmetric shape or symmetric diagram or anything that you want. So basically symmetric here guys, see 2, 4 and 9, these are what? These are the principal diagonal elements. 2, 4 and 9. 2, 4 and 9, these are the principal diagonal elements. So if I just fold out this matrix with respect to this principal diagonal, I'm just going to take this here as the folding fixture, and I'm going to turn it out. So if you do that, this 3 and 3 will overlap. 6 and 6 will overlap 5 and 5 will overlap on each other. Okay, so such a matrix is known to be a symmetric matrix. It means basically all the elements across the principal diagonal elements are same. If here it is 3, here it is also 3, here it is 6, overlapping element is also 6, it's 5 here, overlapping element will also be once again 5. Okay, and this is an important question, guys, with respect to your PGCET examination. Most of the time they ask this question. What is that? Transpose of a symmetric matrix. Okay, transpose of a symmetric matrix. This is a famous question. Many of the times it has been asked, so just remember this. No need to by hand, it is very commonsensical. So transpose of a symmetric matrix, guys, it will definitely go. It will also be a symmetric matrix only, because all the elements are same here, right? Here it is 2, here it is 3, 6, 3, 4, 5, 6, 5, 9. Okay, even if you take out the transpose here, it will remain to be same. 2, 3, 6, 2, 3, 6. Okay, 3, 4, 5, once again 3, 4, 5. 6, 5, 9, and once again 6, 5, 9. So transpose of a symmetric matrix will always be a symmetric matrix only. Remember that, it is important with respect to your PGCT examination. Alright, so once again, guys, this part is nothing new. Okay, so now coming back to the next part, skew of this. Skew. What do you mean by skew? Skew is just the negative version of that. Okay, suppose if I take in if I take in a line here, if all the elements on this particular side are positive, then all the elements on the left hand side of it will be negative. Okay, that is basically skew. If all the elements on the left hand side are positive, then all the elements on the right hand side will be negative. That is what this term, particularly skew, highlights or specifies. So skew symmetric matrix. Skew symmetric. So now, as the name suggests, guys, 2, 3, 4, negative 3, 5, 6, negative 4, negative 6, and 9. Suppose I am going to take out this one particular matrix just for an example cause. These are the principal diagonal elements here that we have taken out, 2, 5, and 9. Now if you observe, guys, 3 and 3 are both overlapping to each other. That would have been symmetric. But here we have also taken out the term skew. So skew means what? If it is positive here, it will be negative here, right? So here it is 4, 4 and 4. The elements should be same, only the sign will change out. Why? Because skew only highlights the sign, guys. Skew has nothing to do with the magnitude or the measurements. So skew means opposite. Here it is positive, here it is negative, here it is positive 6, here it is negative 6. And once more, it should also be what, guys? Symmetric to each other with part of elements. Elements na magnitude ashte idu symmetric irabeko. Okay na? Overlapping elements same irabeko, signs different agi irabeko. Okay, now just in case, if it is 2, negative 3, and then it is what, 4 and 3, this will be a skew symmetric matrix. Okay, because 2 and 4 are principal diagonal elements. Here it is 3, here it is also 3, and here it is negative. Skew means what? Just the opposite sign of that, and that will be positive, and here it is. Hence it is known to be a skew symmetric matrix. Okay now, and one more question, guys, important question. Now see, if you take out just the transpose of this one, okay, take out the transpose, what happens? 2, negative 3, negative 4, and 3, 5, and negative 6, 4, 6, and 9. This is a skew symmetric matrix. We have taken the transpose of this one. So now here, guys, I can say transpose of a skew symmetric will be what? Negative of itself. Okay, suppose there is a matrix B. Suppose there is a matrix B, then matrix B, suppose it is skew symmetric. Matrix B here, guys, is a skew symmetric matrix. Okay, then what happens? B will be equal to the negative version of its transpose. We have to take out minus here. This is the transpose. If you just take out the minus sign here, multiply this each and every element with the minus sign, it will turn out to be what, guys? It will turn out to be basically this element back only. Okay, so here guys, in this particular format, I have taken 2, 5 and 9 to be our principal diagonal elements, but basically most of the time it will be 0. Okay, most of the time it will also be 0. Alright, so this basically guys is nothing but the skew symmetric matrix. Okay, and just remember this condition guys, this condition is important with respect to your examination. This is the condition for skew symmetric matrix. Okay, now many of the times always remember principal diagonal elements in case of skew symmetric matrix will be 0. All right. Okay, so those guys who are watching me on YouTube guys, do like the video, and those friends of mine will be watching me on app. I hope you're able to understand. So now guys, this is all to the matrix, but let me tell you some important questions that you can expect in your PGCT examination. Okay, important question in the sense, I'm just going to tell you of the pointers guys. You have to remember those important points. It will be asked in your examination. Okay, now alright, so just a minute. Okay, so about this trivial solution guys. Okay, trivial solution and non-trivial solution. Okay, see here guys, trivial solution and non-trivial solution. Many a times in your examination of PGCET, these questions will be asked. Tell us the condition for trivial solution. Okay, what is the condition for trivial solution? You have to remember this condition guys. If suppose there is a matrix A, okay, and determinant of a matrix A, if it is 0, then such a solution is known to be what guys? Such a solution is known to be an non-trivial solution. Okay, if determinant of A is equals to 0, it will be what? It will be known to be a non-trivial solution. Non-trivial. See, trivial means what guys? Trivial means of very low importance, of very less importance. Okay, trivial means of less importance. So it is just a condition guys. You don't have to go through with the entire procedure. Nonetheless, if matrices of such form are given in your examination, it will be given on the basis of linear equation. So just remember this particular condition. If determinant of A is equals to 0, then the entire matrix or the entire solution will be known to be a non-trivial solution. Non-trivial means not less important, it is of greater importance. That is what it means. Okay, now so now if basically determinant of A is not equals to 0, then that will be what? That will basically be a trivial solution. Okay, trivial solution and non-trivial solution. Okay, now so remember these values. And one more question, a major of the times in your examination that will be asked guys. Okay, so see here guys, many of the times the question has been asked in your examination with respect to singular matrix. With respect to singular matrix. So what do you mean by singular matrix? If a given particular matrix guys, if a given particular matrix has its determinant to be 0, then such a matrix will known to be a singular matrix. Okay, if a given particular matrix A has its determinant to be 0, then such a matrix will be known to be a singular matrix. So this means what guys? Determinant of A, this is also applicable for the condition of singular matrix. Determinant of A, it is also applicable to the condition of a non-trivial solution. Okay, now Okay, so this is it, guys. With respect to singular matrix, determinant of A is equal to 0. With respect to non-trivial solution, determinant of A is equals to 0. Now guys, just like I told you, determinant of A, if it is not equals to 0, then it is trivial solution, and this condition also applies for non-singular matrix. Okay, it also applies, guys, to what? Non-singular matrix. Okay, so these are the two different conditions that you have to remember, guys. So if you have any doubts, you can ask. Okay, so I think that will be it, guys, with respect to the part of matrices. Definitely there are questions, guys, with respect to your PGCT examination. Those questions will be solving up once again while we conduct of the class furthermore. And now, guys, this is just the continuation part furthermore for determinants. So matrices and determinants is a very simple topic. Okay, so now, guys, one more important term here that I missed, I think. It is about invertible and non-invertible. Okay, invertible and non-invertible. This is basically, there is a formula, guys. See, if you wanted to find out the inverse of a matrix, inverse of a matrix basically is given by a formula: adjoint of A divided by the determinant of A. Okay, adjoint of A divided by determinant of A. Now, what do you mean by adjoint? Definitely I will explain you that once we start explaining the concept of determinants. Adjoint of A and determinant of A. So if in case, guys, if the magnitude here, okay, or the determinant of A here is 0, see, if it is 0 here, then by mathematical form we know any number divided by 0, guys, it will be what? Infinity, right? Any number divided by 0 will be infinity, and 0 divided by any number will be 0. These are two most important conditions. Okay, we are looking at this condition here: any number divided by 0 is infinity. So if in case we want to find out the A inverse according to this formula, adjoint of A divided by 0, this will be what? Is completely infinity. We will not get the value here. Okay, so we are unable to find the inverse here when the determinant of A is 0. Hence, guys, whenever the determinant of A is 0, such a matrix is known to be non-invertible matrix. Why? Because we are unable to find the inverse of this particular matrix. Okay, hence it is known to be non-invertible. Determinant of A is equals to 0, it is non-invertible matrix condition, and it is also what? Non-trivial condition, non-trivial solution, and it is also the condition for a singular matrix. Also the condition for a singular matrix. Remember, guys, these values are basically asked a number of times in your PGCT examination, and many of the students usually get confused around with these conditions only in your PGCT. Okay, and now in case if determinant of A is not equals to 0, then it is what? First of all, it will be invertible matrix. Why? Because we will be able to find the inverse of a matrix then according to the formula. Correct? Suppose this is a formula here. In order to find the inverse, there are number of methods, guys. Row echelon method, normal method, and this formula method. Row echelon and normal method, you don't have that. Basically, you also don't have this one. Just the formula you need to know. Now, in case, guys, if determinant is not equal to 0, we will be able to find something here. A inverse will be something. Okay. Hence, we are able to find what? The inverse of a matrix. Hence, if determinant is not equals to 0, it is invertible matrix. And also, guys, if determinant of A is not equals to 0, it is a non-singular matrix. Okay, non-singular matrix. And now guys, if determinant of A is not equals to 0, it will be a trivial matrix. Okay, it will be a trivial matrix or a condition for trivial solution. And also guys, remember these three particular conditions. In the entire topic of matrices guys, a number of students have doubts or questions or errors with respect to these conditions. Mark these conditions, these are very important for PGCT. You will be able to solve any of the question if you know these particular conditions. Alright, so now guys, if you have any doubts you can ask, and those guys who are watching me on YouTube guys, those guys who are watching me on YouTube, do like the videos guys if you are able to understand. Okay, and yes guys, there is one more condition. When it comes to homogeneous matrix or homogeneous solution, A into X will be equal to 0. It means that suppose A is a matrix and X, this is the matrix of the variables. I'll just take out an example here. Suppose we have 2, 3 and 1 as a matrix, alright, and we have X, Y and Z as variables. Simultaneous linear equations guys, this format applies for simultaneous linear equations. Definitely I'll also solve problems on that furthermore. Just an example here, A represents this particular matrix of elements, and these are what? Coefficient of X, coefficient of Y and coefficient of Z. And what do you mean by X? X is nothing but this particular matrix representing the variables that we have in our equation. If these values here will turn out to be 0, then such a condition will be known to be homogeneous solution. Okay, homogeneous solution. Remember that this condition is also very important. These are the 4 conditions, and if Ax is not equals to 0, it will be a non-homogeneous. Okay, if Ax is not equals to 0, it will be a non-homogeneous condition. Okay guys, so these are all the conditions that you need to know with respect to the topic of matrices in your PGCT examination. Okay, so I hope it is clear guys, everything is clear. Do check out these particular previous classes also guys. If you have any further doubts, you can definitely let me know. Okay, so that will be it for today guys, nothing much to discuss furthermore. I'll start solving the questions related to matrices with respect to the linear equations and simultaneous equation format guys once I start dealing with them. Okay now, so that will be it guys. Thank you once again for those who are watching or who were watching me on YouTube guys. Thank you to all my friends who will be watching me later, and that will be it guys, even for our Rio who are watching me on app. Okay, so be seeing you again guys in the next class. Till then, have a great time guys, take care, bye guys.